last section in chapter 12, 12.6. Systems of non-linear equations. These are ones that are curves, and therefore they may have more than one point where they cross. For example, if you have a circle and a line, you can have 2 points of intersection. If you have two circles, they could have 2. If you have an ellipse, it could have 4, maybe 3. The hyperbolas could have 4. It all depends. So we need to be able to solve multiple equations, and this is where taking a square root of a positive gives you that plus and minus. That's going to be sort of necessary. As an example, suppose you have xy equals 4 and x squared plus y squared equals 8. Now the first equation is really one of ours that we've used before, y equals 4 over x, if we divide both sides by x. So this is in the first and the third quadrant. The second equation is a circle centered at the origin with a radius of the square root of 8. And I don't know if it does this, or maybe it's got 4 points, or maybe it doesn't hit it at all. So we're going to take this. Substitution is many times your best choice. Plug that in for the y. So it's x squared plus not y, but 4 over x squared equals 8. When you square both of those, x squared plus 16 over x squared equals 8. I'm going to multiply everybody by x squared. We're going to assume it's not going to be 0. So x to the 4th. Now the x squareds cancel here, so it's 16, and this is 8 x squared. Let's move that to the other side. X to the 4th minus 8x squared plus 16 equals 0. This looks like a quadratic. So we can say that a is 1 and b is negative 8 and c is 16. And so not x, but x squared is equal to the opposite of b, or 8, plus or minus the square root of b squared, which is 64, minus 4 times 1 times 16. And 4 times 16 is 64, all over 2 times 8, or 2. Well, that square root is not going to make any difference. X squared is going to equal then 4. So x is not just 2, but plus or minus 2. Plus 2, minus 2. So I still don't know if it crosses twice, but if it only gives me 2 points, then probably it's just touching right here. What do I do with these? Let's see. I can put them back in either one of these. This is the easier one. Y equals 4 over 2, or y equals 2. So when x equals 2, y equals 2. When x equals a negative 2, y equals 4 over negative 2, or y equals negative 2. So I think that's the 2 points. It's at 2, 2, and negative 2, negative 2. Here's the 2, 2, negative 2, negative 2. Those are my points of intersections. That solves the system. It may or may not be that nice for other ones. So what if you had this situation? Well, sometimes, and you don't know until you try, you can get rid of some of these powers of variables. And if you get lucky, that will happen. Let's see if we get lucky with this one. I'm going to multiply the second equation, everybody, by x squared. So x times x squared is x cubed minus 2 times x squared. And when I multiply by x squared here, I just get y squared minus y equals 0. Now along with x cubed minus 2x squared plus y squared plus 3y minus 4 equals 0. When you get down to just these linear terms, that's okay. But look at these three. I can get rid of all three of these by subtracting that second one from the first one. Just change all the signs and add if you want to. So this cancels. Let me do this with a different color. This cancels, and this cancels. Remember, this is now a negative 3y and a negative y, so it's a negative 4y. This is a positive 4 equals 0. Or, let's move the 4y over there. 4 equals 4y, y is 1. Not plus or minus, we didn't take any square roots, just y equals 1. This is a cubic, so this is a little bit different graph than circles and ellipses and such. But if I put the 1 back in, what do I get? When y is 1. Let's use that for this one. So x cubed minus 2x squared plus 1 squared plus 3 times 1 minus 4 equals 0. Let's solve that thing. X cubed minus 2x squared. 1 and 3 is 4, minus 4 is 0, equals 0. Let's factor out an x squared. We get x minus 2 equals 0. Well, then either x squared equals 0 or x minus 2 equals 0. That's why you factor it. So this is when x equals plus or minus 0. Doesn't have to be plus or minus. And x equals 2. So when y is 1, you can get two answers. So this crosses at 0, 1 and crosses at 2, 1. Now, will this always work that way? No. We got lucky. We got rid of everything with a power except for one variable. You need that one variable so you can get some value. But it was nice to get rid of a cube and a couple of squares. Look ahead and see if you can do that. If you can't, you're going to have to go back to substitution. And that should be what you need. It just takes some practice for section 12.6.